Question 4 deals with a little bit different kind of oscillation. It kind of looks like a pendulum on the y side, but it looks like a spring and mass system on the x side. So this might be something that will come up, so let's do it. Block slides back and forth on a track with a slight circular curvature where friction is negligible as shown. The maximum height, h of the track, at each end is much smaller than d. Okay, so the center of mass of the block oscillates between x equals negative d and positive d, reaching a maximum height h every time the block is at x equals plus d or negative d. The curve is so gradual that the total distance traveled along the curved portion of the track by the center of mass is considered to be 2d. So in other words, you don't have to make a triangle to figure out what the horizontal distance traveled is. It's just between negative d and positive d. It's just 2d, okay? At t equals 0, the speed of the block is 0. The next time the block's speed is 0 is at time t equals 2 seconds. So that's going to come back to help us or haunt us a little bit later. So part A shows two graphs. Which of the above graphs could represent the kinetic energy of the block as a function of its height on the track, and which could represent the speed as a function of the block's height on the track? Justify both of your answers. So what we know is that from conservation of energy, as kinetic energy increases, gravitational potential energy decreases, and those are both linear relationships. So the linear relationship belongs to graph 2. So graph 2 is the one that would indicate the kinetic energy as a function of the height of the block. And since we know that kinetic energy is 1/2 mv squared, kinetic energy varies with the square of the velocity. That leaves graph 1 to represent the velocity as a function of the height. And we know that that's the case from several problems that we've done. So 3 points for part A. Only graph 1 represents speed, or 1 point for saying only graph 1 represents speed. Okay. Or you get a point for saying graph 2 represents kinetic energy. So for some reason you could just say one of those and you get that point. Another point for a valid justification relating speed to the height and including a specific feature of the graph, it's acceptable to say that speed is proportional to the square root of the kinetic energy. And then 1 point for the justification that kinetic energy decreases linearly with the increasing height. That's part A. Part B says for the system consisting of the block and the earth, okay, so again, I can use kinetic energy and I can use gravitational potential energy because the earth's included. Describe how the mechanical energy of the system changes, if at all, as the block moves from plus d to 0. There's no friction anywhere here, so there's no outside forces, okay? So there's no external work. Mechanical energy is constant. 2 points for that. The rubric says 1 point for saying that the mechanical energy consists of K and UG, right? Because we have the block and the earth considered here. No external work, so mechanical energy remains constant. All right, on to part C. So I had to look at C for a long time before I figured out what was wrong with this graph. It says it incorrectly represents the horizontal position of the block as a function of time. So the feature that is wrong is the period. Okay, the amplitude is correct. It does go back and forth between plus d and minus d, but the period from the graph is 2 seconds, right? The first maximum is at 1 second. The next is at 3. So that's 2 seconds. However, going back to the data, I got to scroll back up. It says at t equals 0, the speed of the block is 0. The next time that the block's speed is 0 is at time 2 seconds. That's not the period. Remember, the speed is 0 twice during the period. Once at minus d, then once at plus d, and then back again at minus d. So the actual period of that oscillation is 4 seconds. The period of this graph is 2 seconds. So that is the answer to that. 2 points there, and there were a lot of different ways you could say this. You can give the 1 point for saying the maximum and minimum of the graph means velocity equals 0, so the period is incorrect. Or you could say the graph should not have 0 slope at 1.0 seconds. All right, that was the first point. Max minimum of the graph means that velocity equals 0, or you could just say the period is incorrect, or you could say the graph should not have a 0 slope at 1 second. Then for the second point, you could say the period should be longer, or you could say the next maximum should occur at 2 seconds, or you could say velocity should be 0 or a flat slope at 2 and 0, or you could say the graph should be stretched to twice its width, which is another way of saying the period should be longer. Okay, so 2 points there, and there was a lot of ors, but a lot of different ways you could get that point. All right, off to part D. Track 2 is similar to track 1, but the maximum height h is greater, still smaller than D. The center of the block oscillates between negative D and positive D. How does the period of this block's oscillation compare to the period of the block's oscillation on track 1? So the answer to part D is the period of oscillation will be shorter on track 2. T is less on track 2. Let me make sure that was how they asked the question. How does the period of the block's oscillation on track 2 compare? So the period is less on track 2. Here's the justification. You get 1 point for that. The justification there is that the average speed, or you could say the average acceleration, is greater, because what's driving this is the gravitational potential energy, right? So in case 2, this is higher. This is the same. This is the same. So this is larger in case 2. So the net force then on the system, therefore the acceleration is going to be larger in case 2. And then a greater average speed means that it's going to take less time to cover the same distance. And as they said, this distance is the same. It's just this distance. So we've got the same distance covered at a faster speed. So track 2 will have a shorter period. So 3 points for that, as I said. Part E, a student derives the following equation for the period of this block's oscillation. So he says 2 pi square root of h squared over 2 times d times g. All of that is under the radical, right? So it says whether or not this equation is correct, is it consistent with your answer to part D? Well, what was my answer to part D? I said larger h, smaller t, right? Now, does this work here? Well, if I have a larger h, that means I have a larger t, so that does not reflect what I said before, okay? So I get 1 point for indicating the functional dependence of t and h. So by saying, well, according to this formula, if h increases, t increases. And then I get 1 point for indicating that that's not consistent with what I said before. Now, again, if you gave a wrong answer before, but you can still get that second point whether or not it's consistent. All right, finally, part F. When the block reaches x equals 0 at the bottom of the circular track, is the force exerted by the track on the block, that's the normal force, greater than, less than, or equal to the weight of the block, and justify your answer. Okay, I hope you guys are smiling at this one because we've done it a few times, right? We got the normal force there, we've got the gravitational force, but we're moving in a circle. So the net force is equal to mv squared over r. That in this case is up, so that's the normal force minus mg, which means the normal force is equal to, sorry about that, mv squared over r plus mg. It's more, right? This is why you feel heavier at the bottom of the loop on a roller coaster. Okay, hopefully that was an easy one for you guys. If not, hopefully it is getting easier and you're getting more comfortable with that calculation. So 3 points there. 1 for saying it's greater, 1 for describing the net force in terms of the weight and the normal force, and 1 point for realizing that the net force is up due to circular motion. So that's it for Unit 6.